Okay, yes, we have a scary story. All right, what is that? Like 10 lines of text? That's a lot for a math question. However, remember, sense the difficulty. We know that this is supposed to be a fairly easy question. It's only the second one in the free response part of the section. And so that means it's probably easy. So your job then is really not about doing elaborate math. It's just keeping track of everything that they're telling us. So let's take it one piece at a time, okay? The posted weight limit for a covered wooden bridge in Pennsylvania is 6,000 pounds. So 6,000 is our limit. A delivery truck that is carrying X identical boxes, each weighing 14 pounds, will pass over the bridge. So the maximum is going to be 6,000. So whatever our truck is, the truck has to be less than or equal to the maximum, the 6,000. So let's use that. So that's going to be 14 then times X, because it's 14 pounds per box, and so that would be a multiplication. If the combined weight of the empty delivery truck and its driver is 4,500 pounds, what is the maximum possible value for X that will keep the combined weight of the truck, driver, and boxes below the bridge's posted limit? So below. So they are also telling us here, right, the same thing, that it's below. Plus 4,500. So we've got the boxes plus the empty truck together have to be under 6,000. And so this is a linear equation, and you might have noticed that and thought about that. I didn't classify this as a linear model, mostly because I just thought most people aren't going to notice that. So it is what it is. You can solve this even without an equation if you really want. It just depends on how you think about it. Regardless, you're going to take that 6,000 and you're going to subtract out the 4,500, and you're going to get 1,500. And then in order to finish that part, you're going to divide by 14. How many boxes can we hold? So 107.1428571. And so this is the case where we need to think about the story because obviously, that's the more specific answer. But you can't have a decimal number of boxes, right? You have 1 box, 2 boxes, 3 boxes. You can't have 3.5 boxes. So we have to just round down to 107 because that's the biggest integer number that you could have had here. So that's it. I guess if I can take this as an opportunity to maybe warn you about one other thing that isn't related to this question. Let's say, for example, hypothetically, when we divided, we got something like 107.9 is greater than or equal to X, whatever. There's a temptation there to say that our answer is 108, because normally 107.9 would round up to 108. But remember, this is a maximum. So even though the closest number of boxes is 108, if we had 108 boxes, we would be over that limit, right? So when we have a story, sometimes the rules of rounding change. And we always either want to round up or down, just depending on the story. In this case, this number would still round down, would be truncated down to 107, because that is the most number of boxes that you can have without going over our limit. Okay, so it didn't matter here, but I know how the SAT works, and I could definitely see that mattering on another question. So I'm hoping to anticipate a problem that you might encounter later and maybe save you those 10 points.